Hello everyone, welcome to your distance formula review. So what is the distance formula? Alright, if you have 2 points, x1, y1 and x2, y2, to find the distance between these 2 points, use the formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And so you're always trying to find how far it is from point A to point B. That's what the distance is for. So your first example says find the distance between the 2 points, -2, -3. So -2, -3 is right here. That's my first point. And -4, +4. This is my second point. Right? So I want to know how far it is from here to here. To do that, all you do is label your points, x1, y1, x2, y2. And then we plug it in. We have the square root of x2, which is -4, minus x1, which is -2, squared, plus y2, 4, minus y1, -3, squared. So then, do not forget, 2 negatives here turn into a positive. So this parentheses becomes -4 plus 2 squared, and this parentheses becomes 4 plus 3 squared. -4 plus 2 is -2. 4 plus 3 is 7. So plugging this in the calculator, make sure at any time you have a negative here and you go to square it, you put it in parentheses. Because if I just typed in -2 squared in the calculator, that is not correct. It will not be the right answer. -2 squared is +4. 7 squared is 49. 4 plus 49 gives us the square root of 53. Now you can leave your answer like that, or for our project that we're working on, you are going to want to type that in your calculator and tell me the square root of 53 is 7.28 units. Now you can, I would round to 2 decimal places on these. So 7.28 is our distance from the first point to the second point. All right, let's do another one. Find the distance between these 2 points. 7, 2. So 1, 2, 3, 4, 5, 6, 7, 2. And 4, -6. All right. So I want to know how far it is from here to here. Plugging these numbers into the distance formula. x1, y1, first point. x2, y2, second point. So our distance, x2 is 4. Minus x1 is 7, y2 is -6, minus y1 is 2 squared. I don't need to change the signs on anything because I don't have 2 negatives together. So 4 minus 7 is -3 squared. -6 minus 2 is -8 squared. -3 squared is 9. 8 squared is 64. 9 plus 64 gives us the square root of 73. And if we want our final answer, that answer would be okay, square root of 73. But we want to make it a decimal. So 8.54, if you wanted to put the extra 4 on there, you could. Like I said, you would only have to round to 2 decimal places. So 8.54 would be the distance. On this example, I want you to write down right here that Mrs. Carson's favorite color is blue. All right, the last example wants us to take these distances. Right, for the last example, we had 8.54 was our distance. And on the first example, we had 7.28 was our distance. that is for a coordinate plane. That's for a grid. Now, let's say we're taking that grid and we're going to blow it up and actually build something with it. Because a lot of times in real life, to build a big brand new shopping mall, you start with a blueprint. And there's a scale on that blueprint. So let's pretend that the coordinates from our first examples are on a blueprint, and they are going to be the new entrances for a shopping center. So we had the points -2, -3. That's one entrance point. -4, 4. There's another entrance point. 7, 2. And 4, -6. So we are pretending that somewhere in here, there's a big shopping center. We have all these different stores in there, okay? But those 4 points are the entrances to them. We want to know what the actual dimensions for the distances would be if you're given a plot of land that is 248 meters in length. So from here to here, this is 248 meters. We're going to scale this, our blueprint, our coordinate plane, to 248 meters. To do that, we have to know how wide our blueprint is. So if we count, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes this way. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes this way. So we have a total of 20 boxes on our grid. If we take our 248 meters and we divide it by 20 boxes, 248 divided by 20 gives us a scale of 12.4 meters per box. So for each box on this grid, from here to here, right, it's 12.4 meters. So if we are saying the distance from -2, -3, and -4, 4, this distance here was 7.28 units, or boxes. If we took that and we times that by our 12.4, we would get 90.272 meters. So when we're building our shopping center from point A to point B, it's really 90.2 meters. That's how far it is from the first entrance to the second entrance point. Then if we did 7, 2, and 4, -6, from 7, 2 to 4, -6 this way, this was a total of 8.54 units. But I need to convert that to meters. So I could take 8.54 and times it by 12.4 and get from this point to this point, from 7, 2 to 4, -6, it's 105.896 meters far. Okay? So hopefully you saw some real life examples of the distance formula, because you can use it anytime you are scaling something. All right, I hope you enjoy distance, and we will see you in class tomorrow.